Alright, I'm going to run through some quick demos here on the Mac platform, just because it's snappier than going over the network. So we'll go into PDL, use PDL graphics Gnuplot, and these can go in your .perldlrc, of course. There's a convenience variable. Let's make a plot of it. Plot x squared. And the plot comes up right away. You can see we've only fit in an abscissa. The abscissas are here. Gnuplot has supplied us with ordinates, just the indices into the variable. Plot is nicely anti-aliased. It's in a program called Aquaterm, which is the default for the Mac. Different platforms have their own default. You can set the default with an environment variable. I'm not going to do much with the regular subroutine interface. We're going to mostly use the object-oriented interface. Let's define an object. We use the exported constructor, and let's do the WXT device, and we'll set the option of enhanced text, which gives us latex style markup. So let's make the same plot now. Legend x squared. Width is, let's do points instead of the default lines, and x squared. Okay, and there's our plot in the WXT device. You can see the points, little glyphs. You can see the legend up here. You can see the ordinate now goes from 0 to 1 because we fed it in over here. So far so good. Let's look at this. This is a curved block of parameters, and each one of those to plot will describe a different curve. It starts with curve options as a hash that describe the appearance of the curve, and those can be fed either as an inline hash or as a hash ref. And then we follow that with data, which is a collection of either PDLs or array refs that contain a column of data each. The collection of them is what Gnuplot calls a tuple, which can have different numbers of columns in it. So we can add a different plot just by doing this. Let's do lines points. That's a poor man's square root, just interchanging the ordinate abscissa. And looks like I mistyped my quote, so let's do this again. Got to use the same kind of quote to open and close. There you go. So there's our plot. You can see the legend is kind of being stomped on by the plot there. So let's move it over. We can replot. Let's do this. I can set persistent options in the object. And these are plot options that describe how plots will appear. Let's do this top center spacing 1.3. We can replot, and the persistent options will now be applied to the plot. So far, so good. Incidentally, over here, look at these numbers on the screen as I'm moving the cursor around. Those are the scientific coordinates of the cursor, so 0.6 and 0.2 more or less. That's useful for reading points off the plot. I can also scroll around to change the way the plot appears. Here I'm using dual scroll on the Mac, which is like a scroll wheel, up and down. If I hold down Shift, it'll go sideways. If I hold down Control, it'll zoom in and out. There are a bunch of options that I could do interactively with this device. This turns on a grid, this replots, this auto scales, just to get back to where we want to be. And there are a bunch of different things we can do with it. Just to let you know that there are interactive features there. Let's add some more stuff just to show you how you can do error bars. So we don't have to start from scratch. We can add more parameters with replot. We can also abbreviate curve options. So here I'm abbreviating them very, very briefly. Let's do x cubed with error, with y error bars, and let's do x cubed, and say, how about x to the 1.5 over 3, say, or 10. That'll fit it nicely. And there's our plot with error bars. Now, we don't have to specify a delta like this. This is the delta y. If we give a 4 tuple instead of a 3 tuple, we can specify the absolute position of the error bars. So let's do 1s of x, and how about sine of x, and maybe 1 plus x squared. You can see on the bottom here we're doing the sine of x curve. On the top we're doing x squared, and that is lines and points. Over here our legend is a little bit off, so let's move that. We can feed in plot options to either plot or replot in a leading or trailing hash ref. So you'll see that in the demos that are coming up. Key left, top left, spacing 1.2. And there we go. There's our finished plot. All right, so moving on. One of the things that bugged me, well, always bugs me, is how do you plot times? So let's do a quick demo of a time plot. We've got so I'll throw up, this is a script I wrote the other day that just scrapes the value of the federal debt from the Treasury, and I'm putting it on the screen just so you can see what it's doing. Let's go ahead and get it. And what it's going to do is just for each month between 2007 and the present, it'll go off and scrape the value of the debt in trillions of dollars from the page, and we'll get back a 65 by 2 piddle. And here's a typical data pair. This is a Unix time in seconds, and this is a value of the debt in trillions. So with that, let's plot it. Let's see. We want to let's do plot xy dog, which will split the 65 by 2 into two 65 piddles. Let's feed in some plot options. That tells it we're going to do time plotting on the x-axis, and we'll tell it how to format that. Let's do month-year formatting. And we'll rotate the labels 90 degrees so they fit. And put on a couple labels here, and let's do y range is 0 to 12. Close everything off, and there's our plot. So federal debt versus time. We've got timestamps on the bottom. Oops, looks like our aspect ratio was a little bit off, so I'll do that. That's some of the terminals won't get those long labels quite right. Others will. You just need to be aware. So I stretched it down and hit replot. We can see the month-year pairs. Here's the debt. Everything's nicely anti-aliased. So now that we've got that, say we want to put it into paper or something, what do? Well, we can plot that a bunch of different ways. Now that we've got our plot set up, we can change the output device. Let's old style. That's the PG plot syntax coming out of my. Let's put it in PNG Cairo, and let's put it in foo.ping and replot. There it goes. Let's get the file. This being a Mac, I can just say open it in a shell escape, and there we go. There's our file, nicely anti-aliased. Here are the plots. This device actually saw the spacing and formatted everything correctly. So this is the ping that we created. We can do that for PDF or a large number of other devices. Just if we want to be dumb, we can generate an ASCII version, and you can see there my terminal isn't quite matching the default size there. 80 by 24 is default, and there's our line. Down here, it couldn't rotate the axes, but they're still there. There's 7 2007 and 8 the 2008s are or on top of each other, 1 2009. Anyway, it does the best job it can with ASCII rendering, so that's kind of fun. All right, so that is 2D printing. Let's look at quantitative images. So load everybody's favorite quantitative image in here. Let's put this back in WXT. And let's see, we want to reset too, just to make sure that all the state is gone. And we'll tell it to display an image. This is a shorthand for that. And of course I can add some plot options. So we've got pixels here, we've got data value here, here's our galaxy, everybody likes that. Of course we can scroll around, in and out, and just like we could before. Let's do, instead of image, we can use something called fits, which will extract world coordinate system information from the image and put things up in scientific coordinates. You can see the reported coordinates are scientific now instead of pixel. That's kind of nice. Let's put a title on that. Okay, what if we want to pull data out? Let's try this. We can read any mouse input we want. Read polygon. There we go. Read polygon is an event loop that uses the mouse reading, and we can draw, say, the core of the galaxy here. And what if I put in a wrong point? Oops! I didn't want that. I can hit backspace and it'll back up. Okay, and there's our polygon. By default, it closes it. So there's our closed polygon. There are the points we registered. The first and the last are the same because it was closed by default. We can modify that. We're not going to now. Let's jump into 3D plots. So let's make an interesting 3D shape. How about sine of pi times, there's the PDL constants. How about that? And let's plot that. And there's our shape. PM3D is a palette mapped curved manifold, so we've only entered the abscissa here, and that's used for both Z coordinate and color. But we can enter four columns. We have 3 for location of each point and then 1 for the color. I've distorted it by squaring the y-val, so you can see the shape is now distorted. We can change the perspective by dragging around here. Take a look at the numbers down below. You can see them changing. Those 4 numbers that you see are the angles around the z and x-axes, and the scale of the y and z axes relative to x. So we can reproduce a particular view. Let's do that, and that'll give us that particular view. We don't have to do things quite so psychedelically. There we are with a grayscale view. And let's do one more thing. This will produce sort of a poor man's shaded view. There we go, with the illumination coming from the right, and I'll leave an exercise how that works. Of course, the image doesn't have to have anything to do with the actual location plots. We can put the galaxy on the same shape. There we go. Many of the other plot styles, like lines and points, work in 3D as well. I'll leave that to you to figure out. Meanwhile, happy hacking and enjoy PDL Graphics Gnuplot.